Okay, we'll continue with this one more part of this astable. That is, now we are designing for duty cycle which is equal to 50%. Okay, before we designed for a duty cycle which is greater than 50%. So we got something 63% duty cycle, but the design was 70%. Okay, now we are designing which is for 50%. So we need to get a 50% duty cycle. For this is a circuit diagram. Okay, we have these diodes here. So IN4001 diodes, and the resistors which we got from the design is 10 kilo ohms, and here the capacitor 0.1 and 0.1. Okay, we need to do circuit connection as per this circuit diagram. So I have done this connection here. So this is a 555 timer, and these 4 pins are used below 4 pins, and here these 4 pins for this timer. Okay, so I have as per design I have taken 10 kilo ohm which is shorted, and again the diodes IN4001 diodes, and the capacitor, one more capacitor is there here. Okay, this is a capacitor, and here one more capacitor is there. Okay, and this circuit will be rigged as per this circuit diagram, and this is for 50% duty cycle. Okay, let's take the readings of this. So the waveforms will be same. Here same waveform you have to get. Okay, for this also for 50% duty cycle. So let's see the first output. That is, we are taking the output near the third terminal, third pin of this. Okay, so I am taking the output from the third pin, and power supply I have used here is a plus 5 volt. Plus 5 volt. This is a plus VCC, so ground has to be done. Okay, let's see the output. That is, from the third pin we are getting this square waveform. So this is a square waveform, and from this we can obtain the T on and T off value. So first, what is the T on? T on, we can say it is 1. Okay, just a second. So T on we are taking here as a 1.4, we can say. So 1.4 into here, or else now this is a T on period, that is 0.4, 0.6, sorry 0.2, 0.4, 0.6. So 0.6 into 0.1. Okay, here we need to take time division here. Okay, so we will continue with the calculation. So here it is T on, we can say it is 0.6. 0.6 into time division we need to take. So T on we are taking 0.6 into time division 0.1 milliseconds. So we are getting 0.6 milliseconds here. So let me check for T off. So T off value, this one we need to take. So again this is also 0.6. Again 0.6 into 0.1. Okay, so 0.6 into 0.1 milliseconds, we are getting this also as 0.06 milliseconds. So what is our duty cycle? Duty cycle is T on divided by T on plus T off. So 0.06 divided by T on, 0.06 plus 0.06. So from this This is 0.06 divided by 0.12. So if we divide those numerator and denominator, we are getting exactly the 50%. So we have designed also for 50%, and this is also we are getting a practical value also as a 50%. Now we shall take 1/3 VCC and 2/3 VCC values, and we shall calculate the frequency of this. Frequency can also be calculated by these values only, that is T. First we need to calculate 1/T. So for this we need to calculate T. T is T on plus T off, or else we can take T1 plus T2. So 0.06 plus 0.06 milliseconds. So we are getting 0.12 milliseconds. So for 0.12 we are getting 625 Hertz frequency, that is 1/T. This is T value, and for this is 1/T, 625 Hertz. So now we can take the 1/3 VCC. So for that we need to take across the capacitor here. Okay, so we are going to take across the capacitor. So for this we are getting the charging and discharging. So first we need to set for ground point. Okay, I am setting this for one ground point here. Okay, and release that ground. So how much it is shifted? So first this part will give the 1/3 from ground point to here. From this ground point to here, 1/3. So it is almost 1 into, we need to take here volt. It is in volt. So now the reading is 1 into 2. So 1/3 VCC is 2 volt. Okay, now we need to take 2/3. So peak value there. So from this ground point to here, it is 1.8 into 2. So 1.8 into 2, 2 8 is 16, 3.6 volt. So these are the 1/3 value and 2/3 VCC value. Okay, this is regarding to the astable multivibrator for 50% duty cycle. We have designed it for 50%, and also we are getting the duty cycle 50%, and this is the frequency. We have designed frequency for 1 kilohertz, and we are getting here 625 hertz. Okay, it is almost equal. So thank you.